how do you take the derivative of a product of two functions? Say you had two functions, f of x and g of x. Well, you know that you would just apply the product rule, which is the derivative of the first function times the second function, plus the first function times the derivative of the second function, right? So it kind of alternates right here, where you take the derivative. But it's not immediately obvious where this could have come from. So I'm going to derive it again. Let's go back to the definition of a derivative. If we go ahead and apply the definition, treat this as like one function, then what we get is, first we have the limit expression as h approaches 0. Now, some people like using delta x because, it symbolizes the change in x that is what the derivative is based around. But traditionally, I think you would use h. But, either way, same idea. And then for the first term, you would just have this, whatever function that you're trying to differentiate, and then input x plus h, right? Or x plus delta x. So, in this case, into both of these x's, we're going to plug an x plus h. And then, for this next term, we have to subtract off just the original function. So that would be subtracting off f of x, g of x. Just like that. And then we divide everything by h. Okay, now I'm going to add and subtract a function that's going to help us do a lot of simplifications. So I'm going to copy this back down. And the function that we're going to add and subtract is this. We have f of x plus h times g of x. But then to be able to cancel out with this so we maintain the original value of this expression right here, we also have to subtract it off. So it's kind of like adding 0 because this and that, they cancel out. So it doesn't affect what we're dealing with right here. But the reason why I added it, and I'm going to put down the over h, is because we're going to try to factor out a function. Take a look at this first term right here, and this last term right here, the negative f of x plus h, right? If we just focus in on these terms, and then notice that they both have this f of x plus h guy, f of x plus h, right? So we can go ahead and factor that out. So I'm going to write down the limit again. We can group these terms and factor out the f of x plus h. So we factor that out. And then what do we have left? Well, from this first term, we have this g of x plus h. From this last term, we have this negative sign and this g of x. So it's just minus g of x. Okay, cool. But we still have these two guys to deal with. But that's also fine, right? Because notice that in these two functions, there's this common factor of g of x, right? So I'm going to actually split up the function. The fraction, sorry. So we're going to group these guys. We're going to add, and then we're going to deal with these two terms. Now, we're going to factor out this g of x, right? So you have a g of x sitting here now. On the inside, you have this f of x plus h remaining. And you also have this negative f of x. Okay, so, and I'm also going to put the h down here because when you split up a fraction, the denominator stays the same. All right, pretty cool. Because what we can do now is, this guy right here, we can go ahead and evaluate it. Remember that the limit of two functions that are multiplied together, right, you can just take the limit of the first function first, and then multiply it by the limit of the second function if they both exist, right? So, we can do that here too. We're going to treat this portion right here, along with the h, as one factor. And we're going to treat this f of x plus h as another one. So, we have the limit as h approaches 0 of f of x plus h, right? Then we have another limit of this guy. But what really is this? Well, here, we don't have a 0 over 0 situation, right? Like if you plugged in 0 for h here, you would get f of x g of x minus f of x g of x all over h. That's 0 over 0. But here, you don't have that problem because you can just go ahead and directly substitute 0 in. This first factor just simply goes to f of x because that h, when you plug the limit in, it simply disappears. So this first function right here in red actually just becomes f of x once you take it once you split up the limit. So there we go. And then notice that we still have the second factor we have to deal with. So I'm going to put down the limit and then put that down. Okay, and you can kind of see here that this is already the derivative of g. I'll get back to that because right here we can also split up this guy. Now we can take the limit of this term alone because this term we already dealt with, right? So limit this g of x guy right here, it doesn't have an h in it, so it's kind of like a constant because it's not really affected by the limit at all, right? You can make h approach 2, and this g of x guy right here is going to stay the same because it just doesn't have an h in it, right? This h right here. So what we can do is just simply move it outside of the limit because it really doesn't affect it, right? So we can move the g of x outside, and then we still have the limit of this remaining factor towards the end here. Okay, cool. So now this is what we have, and it's nice and symmetrical, right? Right here, as we already mentioned, this is just the derivative of g. In other words, we can write this as g prime of x. And right here, equally as nice, we have the derivative of f, right? These are literally just the definition of the derivative applied to the function g and the function f. So this right here is just f prime of x. So writing everything down, this first term we have f of x times g prime of x, right? F of x comes from here, and then g prime of x is just this remaining limit guy right here. Then we add this g of x is already sitting on the outside, right? And then this remaining limit expression we earlier saw was f prime of x. So that's the product rule, right? Because notice that this is identical to that, right? You might have to change the order of addition and then switch around the multiplication a little bit, but at the end, the number is going to be the same. So this and that are actually the exact same expression, and that's where product rule comes from.